Hi folks, welcome back. This is Module 3. I apologize. I lost my voice for a little bit, so it's still a little rough. In this video, we are going to review how to add, subtract, and multiply polynomial expressions. And then we're going to talk about how we can use long division and synthetic division to divide polynomials. We are also going to use these two techniques to rewrite polynomials as a product of their factors and a remainder. If you do not remember how to do long division, please stop this video now, go take a look at Khan Academy, review long division a little bit, and then come back to this. Okay, so in example 1, when we're adding polynomials, we know that addition is, by the associative property, able to occur in any order, and we can regroup terms as needed as long as it's all division, or excuse me, as long as it's all addition, and if we have subtraction, we can think of it as adding a negative, and then it's still all addition. So we can rewrite this as 6x squared minus 7x plus 8 plus negative 4x squared plus 9x minus 5. Okay, so now we can combine like terms. So we have a 6x squared and a negative 4x squared, so we can rewrite this as 6x squared minus 4x squared. And then we have a negative 7x and a 9x, so we can rewrite that as minus 7x plus 9x. And then we have an 8 and a negative 5, and we can rewrite that as 8 minus 5. Okay, so now if we were to combine like terms, 6x squared minus 4x squared is 2x squared. Negative 7x plus 9x is plus 2x. And then 8 minus 5 is 3, so plus 3. And there is our simplified polynomial. Okay, so remember when we subtract polynomials, we are subtracting this entire quantity. So we really want to think of it as 4x squared minus 5x plus 6 minus 2x squared minus 3x. And then when we subtract a negative, really we're adding 1. And then we can go ahead and, again, combine like terms. So 4x squared minus 2x squared, and the x terms, we have a negative 5x and a negative 3x, so we can say minus 5x minus 3x, and then we have a 6 and a 1, so plus 6 plus 1, and combining like terms, we have this is 2x squared minus 8x plus 7. Okay, so distributive property, we are going to distribute all of the terms in one factor, so this is a factor, it's a monomial, to all of the terms in the next factor. So here, we're going to multiply 4/3 x squared times 6x squared. So we're going to do 4/3 times 6, and x squared times x squared is x to the 4th. And then we're going to multiply plus 4/3 times 9, and x squared times x is x cubed. And then 4/3 x squared times negative 12, so negative 12 times 4/3 x squared. Okay, now we need to simplify those fractions. So 4 times 6, remember this is like 6 over 1, so 4 times 6 is 24, divided by 3 is 8. We could also divide both top and bottom by 3, and so we have 8x to the 4th. And simplifying this, both divide by 3, remember that's over 1, so this becomes plus 12x cubed, and then this both divides by 3, so this is 4, so 4 times 4 is 16, minus 16x squared. Okay, so again, with the distributive property, even if it's a trinomial times a binomial, we are going to multiply each member of this trinomial to each member of the binomial. So n squared times n is n cubed, and n squared times 2 is plus 2n squared. And then the next term, so we have 4n. 4n times n is plus 4 n squared. 4n times 2 is plus 8n. And then we have negative 6 times n is negative 6n. And negative 6 times 2 is negative 12. And now we need to combine like terms. So there's only one cubed term, it's n cubed. And then we have 2n squared plus 4n squared is 6n squared. And then we have 8n minus 6n is 2n, and then of course minus 12. And that's our simplified polynomial. Okay, so go ahead, pause the video, try this one, and we will come back in a moment. Okay, so we are going to do this as an example in class, so make sure you bring your attempt. If you have any questions, go back and take a look at the example we just did. It's the exact same procedure. Try to get as far as you can, and we'll answer some questions in class. Okay, so adding, subtracting, and multiplying polynomials is pretty much a review of what we did in middle school in Algebra 1. Dividing polynomials, however, takes a little bit of finesse. So the first thing we need to understand is that when you're dividing polynomials, so f of x divided by g of x, we can rewrite as f of x divided by g of x, same thing, is going to result in some polynomial q of x with the remainder of r. And we can rewrite it like this. So if we multiply g of x times q of x, and then we have that addition of r as the remainder. Now this might not mean a lot to you, and we'll talk about it in class, but the important thing to understand is that this is your dividend is right here. F of x is your dividend. Your divisor is the thing you are dividing by, that's g of x. And then your quotient, the quotient is the q of x plus some remainder r of x. If you do not remember long division, please pause the video now, go watch some videos on long division, and then come back to this in a moment. Okay, so remember in long division, we can divide 672 by 21. If we put 621, the dividend, in this little house, and the divisor 21 goes outside. So really we're doing 672 divided by 21. And so we said, okay, well, how many times does 21 go into 67? And we know that was 3 times. So then we took 3 and we multiplied by 21, that's 63. And then we subtract, and we get 4. And then we bring the 2 down. How many times does 21 go into 42? It goes in 2 times. 2 times 21 is 42, and we subtract, and we get a remainder of 0. So really, we can rewrite 672 divided by 21 as 32 plus 0 remainders, because there are 0 remainders. We can do exactly the same thing with polynomial long division. So I'm going to pause here. I want you to look at this problem right here, this one right here, and I want you to try to work through each of the steps. We are going to do a live example in just a moment. I want you to try to see if you can find the connections between subtracting each part and how they got a remainder of 0, so that we can then write 6x squared plus 7x plus 2 over 2x plus 1 is 3x plus 2 with the remainder of 0. And technically, we're going to write that remainder over the dividend. Okay. Okay, so in this example, we are going to divide 4x squared plus 23x minus 16 by x plus 5. Now, in long division with polynomials, or I should say, in the long division you remember, we write 101. We don't write it as 11, we write it as 100 and 0 tenths and 1 1. And we're going to have to do the same thing with polynomials. So if the largest exponent is 2, we're going to need to write it in a form that includes all of the terms, even the zero terms. Very similar to when we did the octave programming and you had to write the polynomial as a row array. Exactly the same concept. We don't want to skip any terms. So this is already done for us. So x squared, x to the 1, no x, so we're good. Okay, so we write the dividend out, 23x minus 16, and we're going to divide that by the divisor x plus 5. Okay, so in regular long division, we want to know how many times this guy will go into the first couple numbers. But here, since this is a two-term polynomial, we're going to ask how many times does x go into 4x squared? So how many times does 1x go into 4x squared? And so 1x goes into 4x squared 4x times. And now we're going to multiply. 4x times 1x is 4x squared. 4x times 5 is 20x. And then with all division, we're going to subtract. Now this becomes 0. And 23x minus 20x is 3x. Then we bring down the next term, minus 16. Okay, so now how many times does 1x go into 3x? 1x goes into 3x 3 times. And then we multiply. 3 times 1x is 3x. 3 times 5 is 15. And then we subtract. This is 0, and this is negative 31. This is our remainder. That means the quotient, q of x, is going to be 4x plus 3. And the remainder of 31 we can write as negative 31 that can't be divided by our divisor x plus 5. So here is our quotient 4x plus 3, and the remainder of negative 31 can be written as 31 that's not divided by x plus 5 yet. Now, for all polynomial long division, you want to double check and make sure that works. So we can rewrite this as 4x plus 3, or we can remember 4x plus 3 used to be multiplied by x plus 5, and then we had our remainder of 31. So we can write this as a single polynomial. This is the quotient and the remainder. Or we can rewrite the original polynomial as a factor of the, remember that slide that I said it won't make much sense to you? We can rewrite the polynomial, this polynomial right here, is equivalent to the factors of x plus 5 times 4x plus 3 minus 31. And there's our remainder. So these values, this polynomial, is equal to that polynomial. Okay, I want you to go ahead and try this. At least set it up. I want you to, if you want to try it on a separate sheet of paper, try it, and we have plenty of examples to do in class. Okay, the other type of division is a division you've never heard of before. It's called synthetic division. And synthetic division uses the row array that you learned about in the octave unit. And so what we're going to do is we're going to rewrite the polynomial as a row array of its coefficients, as long as the terms are in descending order with any zero terms included. So, for example, if x squared wasn't here, we would have to rewrite it in as 0x squared. So the row array is 2, negative 5, 3, and 7. And we're dividing that by x equals 2. Now, x equals 2, and you won't understand this until later, but that's okay, is actually, we're finding out if it's a factor of this larger polynomial. So when we write x minus 2 as a factor in a quadratic, remember, we can say, well, then x minus 2 equals 0, so therefore x equals 2, and that's where this 2 comes from. So if you remember from quadratics, we said it's a root if x minus 2 could be written equal to 0, and so that's when y was 0. So we can write it as x minus 2 equals 0, so x equals 2, and so 2 goes in this little side. Okay, so once you have this set up, all synthetic division uses the exact same procedures. So make sure you write these in your notes. The first thing you're going to do is bring down the first coefficient. Then we are going to multiply the coefficient by the value of the divisor, which is 2. Because if x minus 2 equals 0, then that means x equals 2 is a root, right? Remember from quadratics. So in this case, we're going to take 2 and we're multiplying here, right? We're multiplying. I'll put a circle. So 2 times 2 is 4. Then we're going to add down. So we're going to add -5 plus 4 is -1. And we're going to repeat this procedure, always going back to this 2 here. So 2 times -1 is -2. And then we're going to add 3 plus -2 is 1. Repeat. 2 times 1 is 2. Add 7 plus 2 is 9. Now we can rewrite this as, remember we divided out an x term here basically. So instead of having a polynomial of x cubed, now this is going to be 2x squared minus 1x plus 1 with a remainder, remember this is the remainder, of 9. So the answer to this, so the solution to 2x cubed minus 5x squared plus 3x plus 7 divided by x minus 2 is 2x squared minus x plus 1 plus the remainder of 9, which can be written as 9 over x minus 2. That means that this polynomial can be written, so is equal to x minus 2 times 2x squared minus x plus 1 plus 9. So remember, we can rewrite it as the divisor times the quotient plus the remainder. So this polynomial is equal to these two factors plus a remainder of 9. And we'll talk about why that remainder is important later. Okay, let's do one more, and then I'm going to have you do a practice, and we'll have lots more practice in class. Okay, so if I want to divide 3x cubed plus 5x minus 1, remember when we wrote the row arrays, all terms had to be included in descending order. So we need to rewrite this as 3x cubed plus 0x squared plus 5x minus 1. And we're dividing that by x plus 1. So if x plus 1 equals 0, then x equals -1. So I'm going to put -1 in the little box, and then I'm going to write my row array. So 3, 0, 5, -1, and I'm going to check. 3, 2, 1, constant. Okay, so now my synthetic division is set up and I'm ready to go. I drop down the first coefficient, so that's 3. Then I'm going to multiply -1 times 3 is -3. I'm going to add 0 plus -3 is -3. -1 times -3 is +3. I'm going to add 5 plus 3 is 8. -1 times 8 is -8. I'm going to add -1 plus negative 8 is negative 9. So I can rewrite this as 3x cubed plus 5x minus 1 divided by x plus 1 equals 3x. I know this is squared because I started with a cube. So if I'm dividing out an x cubed, divide out an x, you have x squared left, minus 3x plus 8 minus, this is my remainder that I'm going to write over my divisor because that was not able to be divided up. So there's my quotient and my remainder as a fraction. Now that means that I can also write 3x cubed plus 5x minus 1 as a product of the divisor x plus 1 times the quotient 3x squared minus 3x plus 8 minus the remainder. Now what I want you to do is take these two products and minus 9. I want you to go ahead and distribute these and see if you can get back to 3x cubed plus 5x minus 1. Okay, go ahead and try this. Pause the video. I left the answer down at the bottom so you can check and make sure that you're on the right track, and we'll talk about this in class tomorrow. So, for more examples, go ahead and watch the More Examples video. Otherwise, go ahead and complete the 3-1 Polynomial Operations reflection. Up next, we're going to talk about some polynomial functions.